Thank you, Professor Ritesh. Namaskar. Good afternoon to all of you. At the outset, I thank the organizers for giving me this opportunity to present on today's topic, case studies on punch-through and site-specific assessment of Jacob rigs. I hope I'm audible to all of you. Please type out yes in the chat box and also the place that you are joining from, so I know that you are all from different places and I can send my good wishes to all of you. So with this big background, thank you, Ritesh, for an elaborate introduction too on myself. I can elaborate with this big background. So let me just start the presentation. So I keep conducting a workshop on geotechnical assessment of Jacob rigs and also the site survey of offshore projects. So keep watching our social media and the website to join to all of you. Yeah, thank you, Samit. Whenever we have rolled out, we did one about a few months back and we are planning to come up very soon. So I'll give a bit of quick background to the offshore geotechnical engineering, and I will also present the procedures of site survey, how important it is in the context of the Jacob rig assessment, and then I will take you through some quick few case studies on the Jacob rig assessment, the precautions that we need to take care, and those projects that I'm showing here are those which I was physically involved on the site. And also there's one project that I wanted to sensitize on the diameter effects of Jacob rigs when we are making the analysis and assessment. And towards the end, we are open to have discussion, your comments and feedbacks, and any suggestions you have, any questions you have, I'll try to answer as much as I can. So the offshore site survey can be characterized because this is the first step in assessment of any offshore structures to have the survey carried out and get the information. We categorize the projects into different categories. The near shore is up to 15 meters water depth. Shallow water is up to around 150 meters water depth. In the context of Jacob rigs, I think probably 100 to 120 meters is the limit that we currently see on the capability of the Jacob rigs to operate. If it is beyond 150 up to 1500 is deep water, so the fixed mobile offshore drilling unit, the Jacob rigs cannot work here, so they resort to different methods, the floating structures, and you have this ultra deep water 1500 to 3000 meters too. These kind of Jacob rigs are not applicable in those deep waters. So the Jacob rig is a ship by itself, which has 3 legs, which will float on water, and it will be towed by the tugboats, and this part of the ship is called the hull. So at a location, it is positioned, and the legs will be lowered down into the water and touches the seabed. Slowly, at that location, the entire ship is lifted out of waters, whereby the weight of the ship is transferred to the legs, and the legs starts penetrating below the seabed. So once it stops penetration, and then you are rising this hull to the required air gap, then the cantilever will come out and then they'll start for drilling. So when does the leg stop? How deep the leg will penetrate? The leg will stop where the ultimate bearing capacity of the soil exceeds the allowable applied load on the legs. Okay, so now once you have installed this fixed jacket, this is for an open location where you want to do the exploratory wells. Now once the fixed platforms are installed, you can see the jacket structure. The Jacob rig will come adjacent to the jacket structure for the second time to drill the well through the conductor pipes. Here it is, the jacket structure, which is already installed on piles. Okay, and then the Jacob rig will be positioned adjacent to the platform. The cantilever is going on top of the jacket through these conductor guides to drill the wells. So what is geotechnical challenge for this condition? So the geotechnical challenge for this condition for the Jacob rig is to assess the leg penetration analysis, the potential hazards that it will undergo during the leg penetration. For example, the punch through, I will discuss that in a bit. And also when this jack-up rig comes next to the platform, it forms a huge crater around the spud cans that will disturb the soil zone around it. And also the effect of this on the existing pile foundation is a soil structure interaction problem. You need to take care to assess if there is any precautions you have to take for the stability of the platform itself. So in order to proceed further with the assessment, we need to have an integrated approach of site survey. Always we advocate an integrated approach, particularly in offshore or land doesn't matter. First, perform a geophysical investigation and develop the assess the geohazards, then develop the scope of geotechnical investigation, use all the information together. So therefore, the site characterization adopts a multidisciplinary approach, which involves the site investigation, the soil investigation, the geophysical survey, design hazards, and so on. So the geophysical survey consists of the bathymetry survey to determine the water depths, identify the potential hazards like your seabed obstructions, the existing pipeline, the submarine cables, poke marks, buried channels, outcrops, etc., which are detrimental for the safety of the jack-up rigs when it is moved to the location. So this geophysical survey will also aid in evaluating the engineering characteristics of the shallow soils. Correlation of seismostratigraphy with borehole for evaluation of soil over the foundation depths for rig emplacement at locations offset from the boreholes. So between the borehole, the geophysical lines are drawn, the survey is carried out, and then you try to get the sub-bottom profiler to verify the lateral extent of continuity or discontinuity of the layers. There are certain locations where they perform the geophysical and geotechnical borehole data and then put that into form of a geological model, and establish that the geological model is used to evaluate the characteristics of the ground for any subsequent moving of the rig to the locations. Normally for the survey, geophysical survey, the hydrographic survey consists of the echo sounders, could be a single beam or a multi-beam, side scan sonars to get the image of the seabed, and sub-bottom profile to get the vertical stratigraphy below the seabed. The echo sounder is single beam, it's at a point. The multi-beam is a swath. You can get an array for a wide coverage, and this will also give you the condition of the seabed, if there are any mounds or is the seabed flat, etc. The side scan sonar will actually collect the picture of the seabed image to see if there is any undulation in the seabed, if there are any rock outcrops, if there are any debris present in the seabed. This can be done by the towfish for conducting the survey. And here is an example of the side scan sonar. You can see the sand, fine sand layers at the surface of the seabed. You could see the sand ripples. Sometimes this side scan sonar reveals that the sand ripples will be very huge, about 2-3 meters. Like you can see here, the sand waves. If you see these ripples, it's very challenging for the rig to move in the locations, because you cannot soft pin or bring the spud cans closer to the seabed as the hull is pulled by the tugboat before it position. If it touches on these sand waves, will actually affect the stability of the rig. And moreover, at the locations when one of the leg is on top of the mound and the other leg is on the trough, that leads to instability of the rig. So this survey data will definitely guide us the proper way of moving the rig to the locations. If there are any shipwrecks, the side scan sonar image will capture that, can be avoided. It can also give you information about the pipeline or the data. Now the sub-bottom profile could be using a boomer or a sparker for a homogeneous profile. It could be a chirper or a pinger for a shallow depth of investigation, that you can get the data in the surface about top 10 meters. that is very widely used. If you have homogeneous materials about 40-50 meters, boomers are very used. If you have complex stratigraphy, then high energy sparker is used to get the stratigraphy below the seabed. And this sub-bottom profile will also give an indication of the buried channels that are very problematic, and you cannot position the rig in this channel because this channel is a river several thousands of years before, and now the recent young formation has come up. And the material within the channel can be potentially variable, so you cannot predict that. And also you will have these weak flanks where the rigs positioned at these slopes are detrimental for safety. It can slide, so we have to be aware of the location of these channels and avoid if possible. So I'll show you one data as well, how the geophysical data help us to take decisions to move the rig outside the influence of the channels. The sub-bottom profile can also assist in geohazard assessment, planning geotechnical surveys, cable route survey, imaging subsurface structures, geomodeling, identifying corals, marine habitats, and so on. So we talked about the echo sounder, the bathymetry. We talked about the side scan sonar to get the image of the seabed, and the sub-bottom profile to get the stratigraphy. And here is one sample data of sub-bottom profile. The blue one is the seabed. Then you have layer 1 is the very soft formation. The red one is your channel feature. Okay, and then you have other subsequent layers below the channels. Sometimes the sub-bottom profile will also indicate the presence of shallow gas, which is an accumulated gas which is under high pressures. You can't puncture. Probably there's a chances of blowout. So you have to be very cautious and careful if you suspect, and if you identify that the shallow gas is available through this geophysical survey, so that you can take subsequent precautions. So once the geophysical survey is done, then you can identify the geohazards, which is described as the site and the local conditions having a potential of developing into a failure event or loss of life or investments. So what is the hazard as far as the jack-up rig is concerned? So one of them is your uneven seabed, like your sand dunes or sand ripples. One of the most challenging hazards is the punch-through hazard. So that occurs from the presence of a desiccated strong layer underlined by the weak layer. And these desiccated layers can exist at the surface or at a certain depth. So what is this desiccated layer? Perhaps that could be the top of the seabed several thousands of years before. So with repeated fluctuation in the water depth, this desiccated layers becomes very strong, very hard, and you have a weak layer below that. So when the rigs come to a location, when the hull is raised out of water, these crustal layers will break and the legs will punch through and have a rapid leg penetration. So if all the legs penetrate simultaneously, perhaps it's also not intended, could be okay, but we are not sure on the thickness of the crust at each of the leg locations, which could be around 40-50 meters apart. If one of the leg locations has a thinner crust which breaks first, then that leg will punch through or penetrate first, where the ship will tilt to that side, which creates a leaning instability and change the center of gravity, and you will have the accidents happening. So it's important to assess the characteristics of the ground in identifying the crustal layers, the thickness of the crustal layers, the shear strength of the crustal layers, as well as the shear strength of the layer following the crustal layers in order to have the punch through assessed and also the risk of punch through. So the jack-up rig is elevated, then this will start penetrating. You see the sand is also stronger than the soft clays, then this cover can happen, or if this treated as a crust layer, it could also penetrate because there is a settlement of the soft clay layers, and suddenly the rig will start penetrating below those layers, and passing through that, it could stabilize somewhere into a competent materials where your shear strength can increase, or you can have a high bearing capacity material. So when you have a channel, if you are really moving the rig into this channel, I said this potentially variable materials, you end up having a very weak formation, and a very weak formation with the top crustal layers will also lead to rapid leg penetration in this channel. So it's best that we tend to avoid this jack-up rig to be moved in this location outside the influence of these channels. And you can do that only when you have the geophysical data. If you don't have a geophysical data, then you cannot get the decisions. So invariably in the offshore environment, particularly whenever the rig is moved to a location, you perform a geophysical data ahead of the geotechnical data. And that's the normal procedures. But we have seen at times the planning are not so advanced, and you will have the survey parallelly being done, the geophysical and geotechnical data. So before you get the geotechnical results, already the geotechnical borehole is performed. So then you identify these channel features, then it's too late that you cannot, you have to avoid, because already the borehole is done. And we have seen that in many cases, and therefore we urge the clients to make thorough planning where you send the geophysical survey first, get the data, then you go to the drawing board, do the desktop analysis, then you perform the geotechnical data, so it will have a meaningful results. So the geohazards can lead to distress of the legs when you have a rock outcrop, when you are pulling the rig to the locations. If it is lower to the seabed to pin, we do the soft pin in soft place. Perhaps the soft place is no problem, but you have the rock layers when the bottom of the spud cans is touching the rock layers and you're still pulling the hull, and then probably it will bend and you'll see the distress in the jack-up rigs. So when you see from the geophysical data that rock outcrops, perhaps this has to be sensitized to the rig mover for taking all precautions to move the rig appropriately, that would not affect the safety of the rig. So the geotechnical data usually will be different modes, the seabed non-drilling mode or the drilling mode. For the jack-up rig requirement, the depth of investigations usually will be in the order of about 1.5 times to 2 times the width of the spud cans below the predicted penetration. So in such case, if you have say 15 meters of spud can diameters and you predict the penetration to be about 10 meters, you need to have at least about 30 meters of the depth of borehole. So the seabed mode of testing or in-situ sampling would not achieve that much of depth. So therefore, we always resort to the downhole mode by drilling the borehole with the seabed templates on the seabed. The drill pipes with the drilling bit is lower to the seabed. You collect the mudline samples and then you start collecting further samples or in-situ test, as the case may be, depends on the prognosis, to reach your target depth of the borehole. There are several geotechnical dedicated drilling rigs that are operating in this part of the world, in India, Southeast Asia, and Middle East. Perhaps I have been working on these rigs, these vessels, representing different oil companies for nearly 25 years. Almost every rig that is operating in the region, I have worked on those rigs and also assessed those performance. And one of the foremost important aspect in the geotechnical investigation is establishing the mudlines. Many times we miss that. Okay, so how to establish the mudline? There are different ways of doing it. One is to get the water depth and collect the samples, and if you're able to see the samples for the water depth that you are known from the bathymetry, then that's the mudline. The best way to establish is to get this bottom sensor into the drill pipe, which come and nicely rest in this landing ring, and you will lower this drill pipe slowly where this tool will touch the seabed. You have a switch at the bottom, so when it touches the seabed, when the switch closes, you put a bulb and you will see the bulb glowing. So 2 or 3 times you do it and you establish the mudline and you mark 0 on the pipe. And that is the first step in geotechnical investigation. And immediately you collect the samples, you get the mudline samples and you test it, and you already have the shear strength at the mudline. Following this, you wash the borehole to the next depth, incrementally maybe a meter down, and you collect the samples and then continue the process until you reach the desired depth of the borehole. For every meter of sample you recover, the practice is to perform the minimum number of tests, that is at least one torr test to determine the undrained shear strength, mini test, pocket pentrometer, water content, unit weight, reaction to HCl, and UU test. So these are basic minimum for every location. And one important aspect is to identify the structure of the soil, whether it's expansive. If it is indicating expansive, that means you are susceptible for shallow gas and this lichen-sided or fissured material. If it is fissured, then you have to degrade your undrained shear strength, which the jacob rig, in the context of jacob rig, it may experience additional settlements. Finally, you pack these samples to the laboratory for further testing in the onshore laboratory. So the success of integrated investigation depends on well-prepared budget, good planning, attention to quality, safety to obtain an acceptable risk profile. So what is acceptable? So we need to have enough information to depict three-dimensionally, both vertically and laterally. So you could see here the strata are laterally continuous, and it is traceable. If you have different boreholes, between the boreholes, you'll be able to trace the strata. So the common mistakes here I have indicated, so it's all self-explanatory. So these common mistakes result in failing to perform the required investigations, poor quality, and one of the important things is temptation of the crew to imaginary fill the gap. So now just imagine you miss out the crustal layer and you tend to fill the gap, then you are actually losing out whether the rig will punch through or not punch through. So that sensitivity is that we need to have a continuous record, particularly assessing the performance of this jacob rig. So let me illustrate 2 or 3 quick examples of foundation assessment of the jacob rig. So when you look at the statistics and the data, so different geographies like in Indonesia, it's all normally consolidated profile. In Thailand, Malaysia also is similar. You have the crustal layer. East coast of India has under consolidated very deep deposits of soft clays. So the penetration of rigs of 30-40 meters is not uncommon. On the west coast of India also you have soft clays, so have cemented calcarenate layer. So it's potentially variable layer. And you see the water depths in the regions. Okay, and the east coast of India, shallow water is up to 20-30 meters, but beyond that, it's all going to deep water. So the rig will arrive at the location, the legs are lowered down, and slowly the hull will come out of water and it will undergo some kind of penetration. So under self-weight, and then you apply additional preload to sustain the environmental forces. That is done by pumping the water into the tanks surrounding these legs. There will be around 3 or 4 tanks around each of the legs, and you pump additional water. So this will experience additional penetration. The foundation is fixed. The spud cans are generally circular in shape. So although it's different in shape, we take an equivalent circular foundation. Sometimes the jacob could also be connected at the base with a mat. We call it as a mat. So if it's a normally consolidated profile, your bearing capacity is simple to assess, and you can see that increasing bearing capacity with depth, and this is your lightship load. And from the lightship load, you apply additional preload and it will experience additional penetration, and this is the final penetration. Now if you have a hard layer below a soft layer, then you will not experience additional excessive penetrations because already the material is competent enough. But in case of punch through, I said the crustal layer, it could exist at the surface, or it could exist at a certain depth where you have a young formation above. The legs will penetrate this young formation, and then from the lightship load to the preload, this rig is susceptible for rapid leg penetration. Okay, and we have to be very, very careful. If you are not careful, probably you will lead to accident. And you could see one of the rig recently, well, as though we lost it due to its punch through problem. It sank in offshore Malaysia and it has to be taken off. Not only during the rig move at a location, but it's also risk to tow the rig during the monsoon season. So harsh environment, you have to be very careful on the weather conditions before you move the rig from location to location. So most of the jackup rig accidents are due to punch through in nature. Out of the 40% geotechnical in nature, punch through contributes significantly among this number of accidents. So we have to be extremely careful for punch through. So there are two factors to be kept in mind. That's of very, very relevant for us. One is the peak bearing capacity, which we will get the factor of safety. This is the peak bearing capacity divided by the preload. That is your factor of safety, and the measure to required strength ratio. So from the preload, how far that is the minimum value is away. So it obviously should be close to unity, then only you see there's no punch through here. If this is less than unity and this is close to around 1.2 or 1.3, and definitely this crust will break and this will undergo rapid leg penetration. So for every location, you understand the stratigraphy and strength parameters and evaluate the leg penetration curve. This is simply a bearing capacity problem. I would say it's a reverse bearing capacity. So we normally use the bearing capacity theory, and you have the ISO or the Islamic guidelines. You can work out the bearing capacity. It's a simple 𝐏𝐻 bearing capacity that can be utilized. So one data I'm showing on the screen, which has a very soft clay up to around 3 meters. Then you have firm clay, followed by a crustal layer. Then you have a weak material, is a stiff clay. Then it increases with shear strength with that. This is one of the locations, starboard locations. Then you have the other two legs of similar stratigraphy. So the contractor make an assessment of the leg penetration, and he predicts that the leg will penetrate up to around 32 meters. Okay, only the lower bound and the upper bound. The lower bound is predicted to go as deep as around 32 meters. Okay, so this location, 32 meters of leg length, about 80 meters of water depth. You need to have a 10 meters of air gap, maybe another 5 meters of reserve length. If you add up together, the available leg length was insufficient. So the client was very puzzled that the rig was chartered for nearly 2 years, and this location from the contractor suggests that the rig cannot be used for the location used for the project, and they have to de-hire, they have to charter. So we looked at the data, the same data which I was managing on behalf of the client, looking at the geotechnical investigations and also every samples that's taken. So I actually, then it was way back in 2013, I stopped the borehole after reaching around 1.5 times the depth of borehole below the estimated penetration, right? So I already estimated that it should stop somewhere at the top of the crustal layer and then terminate the borehole. So I re-looked into the information with the rig that they gave us and predicted that it would stop somewhere between 19 to 30.8 meters. So where is 14 meters to around 32 meters? So in this case, the leg length was sufficient, and in this case, the leg length was insufficient. So the client was confident to use this data, and the warranty surveyor approved the rig, moved to the location. The drilling was over, and recently last year, I happened to meet this gentleman who was the president of the company. Earlier, he was a drilling manager. So I interviewed him for publishing in one of my upcoming book. I'll share that towards the end of this presentation. So there could be some wrong judgment. If you closely observe the shear strength profile, up to about 5-6 meters, you have very weak profile. From 6 meters to around 13 meters, 13, 15 meters, you have lot of sand inclusion, sand and silt inclusion. So this is very thick, a strong layer compared to the upper weak layer. But also we have to be mindful that there is a weak layer below the strong layer, right? So it's a strong over weak, it's a punch through case. But if you are not experienced, if you're not aware of it, the engineer tend to predict the leg will stop at the top of the crustal layer. So notwithstanding the fact that there is a weak layer below the crustal layer, and therefore the rigs were predicted to stop at the top of the strong layer at around 10 meters. But actually when the rig went to the location, it punched through and it stabilized at around 25 to 28 meters. So that really surprised everybody, because there was approval from all the stakeholders, and subsequent investigation was performed with the quality control by inviting the experts, and I happened to work on subsequent locations to oversee the geotechnical investigation. And this leg I back analyzed. These are the predicted penetrations. So at a light ship load itself, the rig punched through because there was a strong layer, but below the strong layer there was a weak layer, and the legs went through at this depth. Okay, so you have to be extremely careful in assessing the stratigraphy and also the punch through assessment. It appears that this is a simple bearing capacity problem. Yes, it is a simple bearing capacity problem, but the soils are not simplistic in all the locations. So it's complex. We'll have to identify those complexities and tend to address this simple problem. Otherwise, it becomes too complicated. So this is a channel feature, and this channel feature, so usually the survey is performed with the dedicated drill ship. Many times the planning is such that you don't have the rigs available, but the rig has to move to the location. So in such case, it's the last resort. The rig will be moved to the locations. It will be soft pinned. That means it's just touching the seabed. And then you utilize the drilling rig of the jackup barge to do the borehole and collect the samples. You send out some drilling tools, rig tools, and then you collect the samples and you make a spot assessment. And once you issue the report, and the rig will be preloaded, and then it will be lifted out of water. So this was one case. There was no geotechnical data. At this location, the data was collected from the jackup barge itself, and we predicted that this would be the form of the leg penetration. Obviously, a rapid leg penetration could happen somewhere from 4 or 5 meters to stabilize at around 20 meters. With this kind of assessment, I think it's extremely risky to get any approval from the warranty surveyor. They denied approval. So we went back to the drawing board. I think the client looked at the geophysical data where the drilled location is exactly in the channel feature. Okay. Now they said, okay, let us move this towards the south, about 200 meters towards the south, where these two legs, and this is the bow leg. So you're moving to the left side 200 meters. That means these two legs are almost on the virgin ground, and one leg at the back is not on exactly on the virgin ground, but it is slightly away from the virgin ground, but not exactly on the channel feature 2. Okay, they felt happy. Okay, let us move this 200 meters, and we did the borehole again one more time, and we ended up having this kind of curves. So just ignore those dots, colored dots for a while. Now, when you look at this, 7.2 meters to 4.2 to 7.2 meters. When they actually did the preload, one of the leg, it went down to around 9.5 meters. Still puzzled. What is the reason? So let us get back. This leg, when they moved 200 meters to the left side, was still close to the channel, is not away from the channel. Okay, so that's how this leg here experienced around 9 meters. But the other two legs were already on the virgin ground, which experienced only around 4.2 meters. Now with this differential penetration, they're still skeptical whether it's okay or not okay. So then they plan to have a 10% additional preload. That's where you see these two data points are 10% higher than the vertical preload line. So with that 10% additional preload, it did not experience any settlement, which gave confidence that it indeed is in a competent material. So that then they leveled the rig, jacked up to the air gap, and then continued for drilling. Just imagine if you don't have a geophysical data, perhaps you would not have been able to make this decision for this project or for this location. So another set of data which with the geophysical information which can be useful to make decision is a tripod jacket. Once it is installed, the jackup rig was planned to come to the location. So it's always customary that you should get the geophysical information ahead of the geotechnical investigation. So this is one such case where it was both parallelly mobilized. Geophysical survey was carried out, geotechnical borehole was carried out, and you finish the geotechnical borehole. And then the geophysical data come and they revealed that is a channel feature. So you're looking at the plan. The orange color is a channel feature. Okay, this is a channel feature. Red is the first location. The borehole is already done, but I cannot move in this channel feature. Then they said, okay, let us go to yellow location. Although it is devoid of the first channel, that is the orange color one. This is the orange color one. It is still within the influence of the second channel, right? Still is not okay. Okay. Now this borehole was not done. The first borehole was already done. Now when the geophysical data was available, so it was deliberated, and now they tend to locate it at the green location. At the green location, it is devoid of both the channels on both the direction, and they were very confident to go ahead and do the geotechnical borehole again and move the rig in these locations. So without geophysical data, you wouldn't be able to make the decision. So friends, geophysical investigation is as important as geotechnical investigation. So you have to have an integrated approach of site survey for making the assessment, use all the information together, and then assess the foundation for the jackup rigs. So this location is a site specific. So we talk about the leg penetration analysis. So what if the rig has to stay over the monsoon at a location? So you need to make the site specific assessment. We call it SSA analysis, where for additional environmental loads, the lateral sliding, bearing, overturning checks has to be performed. In addition, in this case, the rig was coming next to the platform, which was built maybe around 15 years ago. So what is the effect of this spud can on the stability of the existing jacket was also to be assessed. So here is the spud can details. Normally the total leg length, this is fixed, okay. And tip of spud can, the tip of spud can is the elevation of the pointed tip from the widest section is 3.2 meter. The equivalent diameters, although it's different shape, we consider this as an equivalent circular foundation, and you have an area. And preload per leg, 53 meganewton of preload per leg. Light ship load is around 31.7. So 31 to 53 is the preload. So that is an additional ballast of the water. And you have the diameter of the conical tip here, 0.82 meters. This is the geometry of the spud can. So please examine the geotechnical data. You have very soft clays up to 5.5 meters. Then you have soft to firm clay between 5.5 to 16 meters. You have very thin layer of sand, 16 to 18.5 meter. And you have firm clay, and then it becomes stiff with depth. So it's tempting for us to ignore the sand layer if you are making assessment for foundation, maybe pile foundation, it's not very relevant. But in this case, the legs will penetrate to this weak material, temporarily rest on the top of the sand layer, but the sand layer is very thin and the material below the sand layer is also weak, and therefore it becomes a strong over weak condition. So you have to take care of this condition to assess the punch through, and then you see where the legs will stabilize. So carefully examined and made this assessment, including the punch through assessment for the sand layers. It was 16 meters. Usually this penetration on the vertical scale is with respect to the tip, so which is around 3 meters. So 16 plus 3 is 19 meters. So exactly at 19 meters, you see the peak value. And further to this, the shear strength below this is weaker, but is improving with depth, and we predicted it would stabilize somewhere between 28 to around 33 meters, 32 meters. And here is the geometry of the spud cans and the jacket, which is 17 meters away. And you have this disturbed zone 2 times the width of the spud cans around the spud cans. And with this as well, it is 10 meters away from the jacket, and therefore the Plaxis analysis were performed by modeling the spud cans and the pile. We see there is no lateral deformation of the soils. That means there is no effect of the spud cans around the spud cans adjacent to the pile, and therefore there is no need to take any additional precautions. For the environmental force, the 𝐉𝐚𝐻 loading also suggested that it is within the factored load, so it is safe, no problem. And I ran a workshop last year. The rig manager attended the workshop when I was presenting this case, and he did indeed inform me that the legs stabilized between 89 to 91 feet, exactly where we predicted the range. But probably I would say it's a coincidence, because particularly Jacob rig, I would rather look at every location as though I'm doing for the first time. And I urge every one of you, particularly the youngsters, to do the same thing, that you look at problem every first as though it is the first time, regardless of how many times that you have done in the past. Okay, the last case study before I close is a location in the Middle East, which has a very soft lace in the top 0.65 meters. Please, I draw your attention to this rock layer. Is a calcarnite layer, very thin, 0.65 to 1.1 meter. And then you have a firm clay below the rock layer, and it's competent going down. So what's the issue here? What's the challenge? The challenge is the weak material, that is the clay layer just below the rock. So how this will influence the Jacob rig, and what kind of rigs that it will influence? So there are 3 rigs to be analyzed. One has a 17 meters diameter of the spud cans, one has 12 meters, and the other one has only around 6.87 meters. The large diameters, the influence will go to the deeper depths, okay, and the thickness of the soft clay layer below the crust, the calcarnite, is very thin, so there is going to be a squeezing effect to have additional penetration. But when it comes to this small diameter, okay, the small diameters, when you stop of the crust, still the influence, the weak material has a significant influence on this particular Jacob rig. So you have to be very, very careful. Although the thickness is very small, you see the diameter also is very small. So this is the bore log, which suggests the calcarnite layer at around 0.65 meter. And if you plot the shear strength profile, here is the calcarnite layer, and the shear strength is very weak here below the calcarnite layer. And the first Jacob rig, which has 17 meter in thick, experience around 3.3 meters of penetration, because it's going to have a squeezing effect where your competent layer will kick in for the bearing capacity. And same with the 12 meter also, it's so wide that it can kick in from the bottom layers. But for the small layer, those calcarnite layers are so weak, and the material below that also weak. When you lift the rig from light ship to preload, there is a possibility of the rapid leg penetration. unless the rig movers slowly operate it, but we are not sure how they operate. They will lift the rig at a shot at once, then you may experience some kind of rapid leg penetration here. So that may induce some kind of uneven settlements on the rig, uneven penetrations, and that could cause some kind of stability issue. So therefore, you have to be very careful in these locations because of these diameter effects. Okay. So you have seen the stratigraphy in Southeast Asia is normally consolidated profile with more linearly increasing shear strength with depth. If you come to east coast of India, it's 1 megapascal up to around 100 meters, and the over consolidation ratio is less than 0.5. But if you go to the Middle East, the shear strength is around 400 and above kilopascal. Despite this, I just showed you in one of the locations in the Middle East, you may have a problem. So therefore, look at each location every time as though you are doing for the first time. Sometimes these Middle East locations can have an intruded cemented layers, or the cemented layers could be with carbonate content. It's called calconite or calcite. So one size doesn't fit all. So I had the honor and privilege to work in these geographies, and the best way I thought that I can contribute is to put the information in form of a book. The Navigating Offshore Geotechnical Challenge is a compass. And this book considers 5 countries where I have described the general characteristics of the soils, 3 case studies in each geography, and also the challenges this stratigraphy poses to the offshore construction in the light of pipelines, the mud match, jackup, and the pile foundation. In addition, I have interviewed 3 senior leaders from oil company, EPC contractor, and the survey contractors. We had this cover launch about 2 months back. Professor T.G. Sitaram was my guest of honor, and I have given this book for print. It should be available in the next 3 to 4 weeks time. So I'll inform all of you to go through this. It could be a reference guide for those of you who want to really look at what's happening in the offshore. And this is my team. I'm happy to share that I've earned this expert level in the dynamic measurements and proficiency analysis. Having worked on different geographies outside the country, the Indian government getting dollar remittance to the country recognized both the state level and the central level through Ministry of Commerce. And with this, I try to acknowledge the Almighty, my parents, my family, my siblings, my extended family, friends, well-wishers, employers, gurus, mentors, coaches, my colleagues, customers, and collaborators. Thank you so much. I'll be very happy to take any questions. Indeed, it's a privilege to